You are listening to the Wi-Fi Ninjas podcast, where we talk about wireless technology. Here are your hosts, Mac Daring and Matt Starling.
Hey everyone, Matt and Mac here from the Wi-Fi Ninjas, and in today's podcast we are going to be talking about passive versus active surveys. Have you ever heard of these, Mac?
I'm very good, thank you. How are you, Matt?
Very good, thank you. Very good, thank you. I thought I would just skip the niceties today and just jump straight into the podcast.
Yeah, because we've heard people they're complaining that our intro takes too much time. So, Matt, what is the weather like where you are today?
It's not too bad. It's a little bit drizzly, but it's not cold.
How is your dog doing?
Very good, thank you. How's yours?
I don't have one, but otherwise it's very good. Thank you very much. Okay, to the point. So no more intros, right? That was the last time we've done in our lives. So active versus passive surveys. Yes, I did hear about them, I think, in the past. So I always do active survey. How about you?
Yeah, all the time. Active. Sounds
Yeah,
better. Sounds better, so it must be better, right?
Yeah, I don't collect even data because who needs data? We just need to know the throughput, ping. That's what's the most important in Wi-Fi.
Well, it was actually a conversation that started in our UK Wi-Fi Slack channel the other day from Ashley. He brought up about doing some active testing in his Ekahau survey for a customer, and it started a very nice conversation, which then led us on to decide, maybe we'll do a podcast about passive versus active surveys and talk about what's the difference.
It totally makes sense because it's a common misconception about the active versus passive. Some people, they call some Ekahau surveys hybrid and, this kind of stuff. So let's clear that out. Okay. So before we jump into the active versus passive versus hybrid, what data you collect using either of them, let's just start with how do you collect data? What do you use? And what is the real like a workflow to collect data on site?
Sure. So we are obviously quite known for our usage with Ekahau. So we use Ekahau to do our site surveys. So we're going to use it for our predictive modeling, for doing our validation, if we're doing an assessment. So we're going to be mainly referring to Ekahau for passive versus active site surveys. But I'm sure there are other software tools out there that you could use that would support these different features of collecting data for your Wi-Fi surveys. But inside of Ekahau, what we would typically be using to do a site survey for validation or an assessment, we're probably going to be using the continuous mode or potentially autopilot if you're leveraging the iOS apps. There are other methods that we could use like stop and go or particularly like GPS. But that's what we're going to be referring to for when we're collecting passive survey data or active survey data.
Exactly. So it makes sense for us to use Ekahau because we can do both passive and active in one application. You don't have to use Ekahau for active tests. You can use something else, but you would need to use two applications. So whatever is suitable for the application. Stop and go is, in my opinion, obsolete by now. It's been used like before the continuous mode was invented. It means that you go to a place where you want to collect the data about Wi-Fi in the certain area. Then you click and then you wait until the circle makes a full round. It takes like 4 seconds around that with a sidekick with two nicks in each, scanning all the channels. If you, however, divide the channels that you scan between these two nicks so they don't scan the same channels, one of which they scan like around 20 channels, or 120 and 119, it takes around 2 seconds then to scan. So that's how much time it takes to capture every data point with stop and go. So you go somewhere, you click, you wait. Then you move 3 meters away or 2 meters away, you hit the button and then you wait. It's not a problem if you're surveying, your room in your house, but if you're surveying like a massive space, warehouse, open spaces, big office, multi-floor building, it will take you a few years to complete a survey, so it's probably not a good idea. Autopilot is amazing, absolutely smashing. As Matt has mentioned, you require to have the AR kit from the iOS devices. I would just want to add to that LiDAR inclusion in the AR kit makes all of the difference. So if you have a newest iPhone 12, it has the LiDAR built in, or 2020 iPad Pro, it has the LiDAR built in. It just makes it more accurate to the point where it puts a smile on my face every time I use autopilot today. It's that good. Last year it was a gimmick in my head. Today it's my one of the main survey data capturing methods.
Yeah, and in regards to stop and go, I mean, if you're working in a, so let's say like a hazardous environment where it may not be feasible to be doing a continuous survey or an autopilot survey, that might be when we want to leverage the stop and go feature for the data collection, because it might be difficult to get to a certain area that you want to collect the data. Maybe if you're doing, say, a hospital and you're going into some certain areas and you've got to wait before you can get in there, maybe a stop and go is kind of feasible for those areas. But we might tackle another reason why you might want to use stop and go later on in this podcast.
Later on, what is the reason? Okay, cool, I got you. And then lastly, there is a GPS. Of course, it doesn't work too well indoors. It actually doesn't work too well outdoors either. So be careful with that. What I mean by not working too well, it can give you several meters inaccurate results. If you are surveying like an open mine, which is a few kilometers wide and long, then it probably doesn't matter. But if you want to survey some parking lot that is like 20 by 30 meters, then plus minus 10 meters makes a difference.
Yep, cool. Okay, so shall we tackle now then what we collect when we are doing a passive site survey?
We shall.
Okay, so when we're doing a passive site survey, that means we're collecting Wi-Fi data at layer 1 and layer 2 of the OSI model, so the physical and the MAC layer. Not MAC as in Mac right in front of me, but actually the MAC layer.
You can collect me as well.
Okay.
And while collecting me, you can bring a beer and make sure that you are using a nice car while collecting me, because I won't fit in a small one.
Okay, yeah, no worries. So what we mean by we're collecting data at layer 1 and layer 2, so the types of information we're going to be collecting is going to be the received signal strength indicator, otherwise known as the RSSI, noise, SNR, signal to noise.
About noise?
Yeah.
So when you say we are collecting noise, we are calculating noise.
Yes.
Based on what our promiscuous monitor mode NICs built into Echohouse Sidekick here. Okay, we are not collecting like the noise information from the air. It doesn't exist really. It's very difficult to ascertain the noise level with wireless NICs. We would need to use spectrum analyzers for that. And again, it's very difficult to differentiate the modulated signal versus noise using a spectrum analyzer. And therefore, the best way of collecting noise information is to performing a full survey, walking around the site, and then looking at the spectrum yourself. So we can see what is the interference, what is the modulated 802.11 signal, and what is the noise flow.
Correct. And we will be collecting the data rates, as well as the SSID or the BSSID information, the security information from the SSIDs, what PHY type is in use. So we mean like 802.11a, b, g, n, ac, or ax. And if the access point support it, we can collect what the AP name is being broadcasted from the access point. And channel utilization.
Yep. So channel utilization in this example, like inside the Echohouse, that's where Echohouse Sidekick uses spectrum analysis layer 1 exactly to give us like a data. How do you call it? Data cycle, not data cycle. The
duty cycle. Duty
cycle, of course, in percent. If you have access points capable of giving you channel utilization from their end, this is using not only layer 1, but layer 1 and layer 2. So access point sees how many times it can and how many times it cannot access the Wi-Fi medium. And based on that, it will calculate channel utilization. So typically, channel utilization is way higher when seen from the access point perspective, layers 1 and layer 2, when you compare it to just layer 1 reported by Spectrum Analyzer.
Yeah, because I've seen quite a few people, even myself included, before when you'd fire up, say, a Wi-Fi scanner like Wi-Fi Explorer Pro or WinFi, and you turn on the column to show you channel utilization. So you see channel utilization coming in from the Wi-Fi scanner, but then you look at your channel utilization from the data that you collect inside of Echohouse, and it looks quite different from the heat map to what you're kind of seeing. You might see, I don't know, 60% channel utilization on 2.4 gigahertz for one of the SSIDs in the Wi-Fi scanner, but then you check the channel utilization for that same SSID on 2.4 gigahertz inside of Ekahau, and the channel utilization looks like it's around 10%. So why do we see a difference here, Mac, in Ekahau compared to the Wi-Fi scanner?
Yeah, because in Ekahau, you only see the real duty cycle airtime utilization of a physical medium in the air. So how many percent of a time you had data in the air before, above certain threshold. From the access point perspective, it's different, however, because, what happens is you play the game, right? The Wi-Fi game, the CCA, the DCF. You have tons of timers there where you just sit idle listening to the medium. Okay, you have to come down and then wait, and then you transmit and then wait for the acknowledgement. You get the acknowledgement, fine. You didn't get the acknowledgement, then you go back and you wait even longer. So your devices, they won't be necessarily talking all the time, but it means that these devices, they cannot transmit wherever they want. They have to play the game, and they won't be able to play the game to transmit anytime they want. They will have to be polite with other clients. And this waiting times and playing the game, it takes time at which you cannot transmit, which means that the airtime utilization from your client's perspective, from your access point's perspective, will be way higher than the spectrum analysis on layer 1.
Thank you, Mac. Great explanation, and hopefully that makes it a little bit clearer for our listeners, because I've spoken to people before that, sometimes get confused by this between what you see in Ekahau to what you see inside of a scanner, which is completely fair enough. I was one of them a little while ago until we had that podcast about packet captures
with Ben Miller.
With Mr. Ben Miller, very good podcast where we tackled that, where looking at the spectrum utilization from the access points perspective, or looking at the utilization from a spectrum analyzer perspective. So that was very good and helped me a lot. Okay, so that's the information that we collect when we're doing a passive site survey, and we remember that Wi-Fi works at layer 1 and layer 2. So that's the data that we collect when we're doing a passive site survey. So then if we are going to do an active site survey, what does that mean? And what layers of the network are we now looking at when we're doing our testing?
Okay, so I will kick off and then you will put some more information on top of that. So active site survey is upper layers than 1 and 2. So everything that requires the active test of the network connectivity quality or speed or latency or jitter or throughput, it's the active test in a survey. So layers 3 and 4 and upper really here. Mm-hmm. What tests do we have available to us as part of the active survey, Matt?
Well, you can do what's called a ping test. So you can, once you connect, you need to make sure you're connected to an SSID when you're performing your survey. So you'd connect to an SSID, and then by default, usually it's going to try and ping the default gateway of the network. But inside of the Ekahau application, on using your laptop, you can configure this IP address to be something different from the default gateway, to be Google DNS server or the 8.8.8.8. And what it's going to do is going to go off and ping that IP address and then collect information like round trip time and packet loss. And then it will display as you on your floor plan, as you're walking around, you will see a heat map for what the percentage was for your packet loss and the round trip times.
Yep.
You also have another type of active survey testing that we can do, which is called a throughput test, but that requires additional parts that you would need. You would need to have an iPerf or an ePerf server running somewhere on the network. So what I mean by that, you need to use a device connected to the network that your survey device can send TCP or UDP traffic to whilst doing your survey, and you'll get real throughput information for how the network is performing whilst you're doing your survey. You can use just another laptop with an iPerf server running on the device and connect that to the same network that you're doing the survey on, and you would need to configure the IP address inside of Ekahau to go to that iPerf server. Or you can use a device such as the WLAN Pi, and you could plug that into the network somewhere and then use the feature for the iPerf on the WLAN Pi, use the IP address inside of Ekahau and connect to that whilst doing your survey. And then you're going to see the throughput information as well as jitter.
Yeah. Okay. So I think it feels right to discuss one and every active test here, what they mean really for us. Why do we want to use them from the practical perspective, and what do we have to be careful with while
Well,
using active tests?
customers quite often will say to you, "Oh, yeah, I want to see how fast my network can go. I want to see, real throughput data from your when you're doing the survey. I want to see the throughput information in the report. Can you collect that data and give it to me?"
Yeah, but this all comes of the back of misunderstanding of how Wi-Fi network operates from a client's perspective. So what they want to do, they want to connect to the network, associate with the fancy new, BSSID, and run a speed test, and then see something mind-blowing like whatever they've seen in the marketing papers. Like, I can do 7.9 gigs. Yeah, of course, if
Woo!
you have three radios in the access point, 160 megahertz channels, combined throughput from all the radios at the same time, have no interference, no neighbors, and using 10 24 QAM MCS 11, then yes, you can have combined throughput of that, assuming that your device and your access point can do 4 spatial streams as well, which is
It's
not
easy
possible.
to do, right? In the enterprise with tons of other, you've got a multi-tenanted office in central London. You could easily achieve this, no?
Yeah, of course. Yeah, in reality, we don't use 160 megahertz channels. We use 20. We don't have 4 spatial streams devices. We have 1 or 2. And top laptops out there, they used to have 3 spatial streams, but like the top of the range laptops from Apple now, like in 2021, now they are back to 2 spatial streams with an upgrade to Wi-Fi 6, down from 3 spatial streams in Wi-Fi 5. So mostly, I would say we have between 1 or 2 spatial streams, and tons of interference and quite a lot of CCI, especially in areas in major big city centers where you have tons of neighbors, multi-tenants. You have tons of different devices connected to different overlapping Wi-Fi systems, like this, how do you call the click share devices, like the media sharing
Yep.
devices. You have some printers, you have some Wi-Fi, whatever
Door
things.
access. Door access now. One of the sites I've done recently, they had an iPad on every single. They had like it wasn't an iPad, it was like a tablet on every single door that had all the meeting info, and that was actually broadcasting SSIDs.
What?
I
Really?
know. So there's some even door access or door meeting devices now were kind of working as access points. Yeah,
Yeah. That's dodgy.
I know. When I highlight that to the customer, like, oh, they shouldn't be doing that.
Well, we don't know how their system works, so maybe they do need to be doing that. But gut feeling says that it's probably better if you have a system like that to just connect it to your corporate Wi-Fi.
Mm-hmm. So Mac, let's say in this example that the customer has asked us to do some active tests so they can see throughput data in the report from Ekahau. They've gone online, they've seen Ekahau supports active site surveys. So we go on site, we use our iPhone or iPad or our MacBook Pro or our Surface Pro, whatever device, and we go and we connect to the SSID. We're doing a ping test. We've installed an iPerf server on the network, and we are doing throughput testing. We walk around doing our continuous mode survey. We walk all the floors. We walk everywhere. We then retrieve the information from Ekahau. We then run a report on it, and then we put it in a report, and then we provide it to the customer. And now a customer is going to see throughput information, packet loss, round trip time, jitter. What is the customer actually seeing when he looks at this? Is this, for, all devices, when he looks at, he looks at an area on the map and he goes, the round trip time here was crazy. We've got an issue with the Wi-Fi over here, right? And then, over there by the conference room, when you went into that conference room, the throughput dropped from going from 150 meg down to 10 meg. We've got an issue with throughput over there. How do we fix that? Is that what the customer sees? Please tell me and explain to me what's going on.
Lots of questions there. So let's start with where you would position your iPerf server, perhaps, because when you walk around and you do the active throughput tests, what do you do them against? Do you do them against the iPerf server or ePerf server that is sitting locally to your network? Is it in a data center over one link? Is it in a different continent that goes over the one link to your data center that goes over the internet to a different data center, and then this kind of stuff. So when you are doing throughput tests, you want to ensure that you are testing your Wi-Fi, perhaps, right? Maybe not the broadband, not the internet, not the one links at this point. You want to check how capable your Wi-Fi is with your clients. So first of all, put your iPerf, ePerf server as close to your survey client as humanly possible. So if you are connected to the access point that is connected to a switch, plug in the ePerf server, iPerf server to the same switch. So we are not testing the infrastructure, switches, uplinks. We don't do that. We just all live in the same switch, same subnet, same segment of a network. So that's very important. And now you walk around and you would expect, okay, I have Wi-Fi 6 network access points that can do 8 special streams. Does it mean that I can have few gigs of throughput everywhere? You walk around and then you are disappointed because you see that you are just, having 170 megs tops, and sometimes you are dropping down to something like, 35 megs, and sometimes you even go down to like something like 10 megs, and then you scratch your head thinking, what the hell is going on? Down from 170 to 10, then back to 170, then to 10, then to 30, then to 10 again. Is that how my expensive network should work? So Matt, why is that happening? That we have this, massive differences in data rates while walking around with our survey devices?
Yeah, great question, Mac, and one I think that we definitely need to discuss properly, and hopefully, everyone that listens to this and that will have a good understanding of why your heat maps would potentially look like your bad throughput in certain areas. Because when we're doing an active site survey, what we are actually doing is we are testing the Wi-Fi network from the perspective of the client device that we are using at that time. So if you're using a Surface Pro, that's the device that you're using for your active survey data. And what can make the throughput look like you've got terrible throughput, you've got terrible packet loss, you've got terrible round trip time, is it can be a poor roaming decision for that device. And what we mean by that is the Surface Pro, it might be connected to an access point when it first starts to do the active testing. Data rate is the signal, the received signal strength is great. My SNR is great. My data rate is great. I'm getting really good throughput. And then as you start to walk away from that access point, your RSSI will go down, your signal to noise ratio will go down, so your data rate will start to go down. We can use less complex modulation schemes, and that will then mean our throughput starts to go down. And then what happens when we get really far away from the access point? It drops down so much that our throughput goes down, our signal goes down, and the device goes, oh, you know what? My signal now is not great. I need to move to another access point. So what it's going to do, now it really depends on how is the network configured. Is this SSID using 802.1x? Is it just pre-shared key? Is it an open network? Do we have fast roaming amendments turned on this SSID that can help our device transition from one access point to another faster? Or is it going to have to, stop sending data on the channel that it's on whilst it's connected to the access point, go off channel, start scanning to find another access point for it to go and join, which will take time, and then it's going to, join the next access point, go through the authentication process if it needs to, and then whilst all of this is happening, your data that you're sending to your throughput server is going to look like it's going really, the server that you're using doesn't care that your device is roaming. It just sees less data coming to it, and it's going to start to show that you've got poor throughput data whilst, your device moves from one access point to another. Maybe.
Yeah, and what just described is just like a standard, normal, expected Wi-Fi operation, right? While you roam.
Yeah, packets could get dropped. So the round trip time could look bad because, it took a few hundred milliseconds to roam between the access points. So we started to lose some packets. So our round trip time went down, our throughput went down, and then we join the next access point, and all of a sudden our signal strength goes back up. Our signal to noise ratio goes back up. We can use a faster data rate, a more complex modulation, and our throughput goes back up. But does that really mean that in that certain area we have poor throughput? Or does it mean that it's just that device at that time having a bad time potentially?
Yeah, and why is it having a bad time? So you've mentioned extremely important thing. The throughput test happens everywhere. Doesn't matter if you are close or away from the AP. So if you roam, of course, it will go down. Doesn't matter what amendments you use, it will go down. So let's say when you are very close to the access point, Wi-Fi 6 AP, and you have MCS 11 data rate, okay? So you are hitting the maximum throughput that you can hit in the network. You can achieve maximum data rate there. But then you move away like just 7 meters away from the AP in a clear line of sight, you're down to MCS 10, okay? You add another 2 meters, you're down to MCS 9. You're 10 meters away from the AP, you're at, MCS 8, perhaps. So we are not using QAM 1024 anymore. You are using QAM 256, and not even the fastest coding. You are moving down as well when it comes to coding. So you are going slower, slower, and slower, but it's still plenty fast for your device to stay associated to the access point that you are exchanging data with. And then, Matt, what decides about when your device wants to roam? Is that the access point that decides when my device wants to roam, or is it my client?
Yeah, again, really, really good question, Mac. It's always down to the client when it wants to roam, and there can be a whole bunch of reasons of why a certain device will decide to roam, which we refer to in the industry as the green diamond. And what that basically is it's a set of an algorithm of, it could be, it's just something as basic as, what is my RSSI? Have I got, within a certain threshold, say if I drop below -70, I'm just gonna move and try and find another access point and connect to a signal strength that's got a stronger signal strength than, say, -70. But maybe you've got some other devices out here that's got a more complex algorithm that's going to not just look at the received signal strength, it's going to look at the signal to noise ratio, it's going to look at the channel utilization, it's going to look at how many access points are connected to, how many clients are connected to a certain access point, and think, you know what, maybe I don't want to roam to that access point, I want to roam to another access point because of how busy that access point is, and I'm going to have a worse time if I move to that access point.
Yeah, absolutely. So it's like, I think you had a nice analogy with a pizza, right? So when you're a human being and you want to order a pizza, every person will have different favorite pizza ingredients, right?
Yeah, I started to use the Deliveroo analogy.
Yeah, I was using Tinder, but I don't think it's appropriate, so I probably won't.
So yeah, Mac, what happens if, say you and Maggie, it's Friday night date night in the Daring household, and you want to get a nice pizza takeaway. So you go onto Deliveroo, and then you type in pizza in your search, and then what happens?
Nothing. Deliveroo tells me that it doesn't deliver outside of the city area.
That is true. When I first came to yours and we tried to get food and we went to Deliveroo, there was no restaurants that would deliver. But
I have a nice fix for that. I go to the closest petrol station towards the city, and they deliver there.
All right, so you go to the petrol station, you fire up the Deliveroo app, and then you type in the word pizza because you fancy a pizza. So then what happens when you type in pizza into Deliveroo? You're going to get a whole different list of restaurants that will now become available to you. So you'll see, I don't know what you got: Pizza Express, Pizza Hut, another Italian pizza. What's going to make you decide which pizza restaurant to go to? Because you've got a whole list now in front of you. So why are you going to decide what pizza restaurant to go to?
Yeah, so that's my personal preference, right? So maybe I want to have a very thin base, okay, to make it super Italian, and the crusty, edges to make it more like, Napolitan style. And then maybe I don't want to have a red sauce. Maybe I want to have white one. While Matt would look at me thinking, why the hell do you want to have white sauce on your pizza? I only like red. And, so first of all, you need to decide what restaurant you want to order from. So that's probably your extended service set, your access points from your vendor that you will just consider reassociating to roaming to. But then you have plethora of your access points options available to you. And then inside the restaurant, you have different pizza options. What ingredients do you want? And these ingredients will be analogy to the RSSI, to the QBSS information telling you about how many clients you have associated with that AP, what is the channel utilization reported by that AP. So enterprise APs, normally they typically include this information in the beacons that you can tap into and see really. So sometimes, like Apple devices, they do that. They will have a choice of two different APs from the same infrastructure, one with very high RSSI and one with lower RSSI, but still good enough. they will connect one that is least utilized. And it absolutely makes sense, right? So even when you roam to the second best AP, like while moving away from the AP that is serving you, it's still down to the client which access point to connect to, and they might connect to the AP that doesn't give them a maximum available data rate again. So when your maximum data rate is like 173 megs or 216 in two spatial stream 20 megahertz channel short gut interval Wi-Fi 6 MCS 11, you might jump to an AP that gives you 100 megs data rate, and still your device will be super happy. And what I mean by your device being super happy, when is your device happy, Matt? So what are the best tests that you can do in the network while testing Wi-Fi actively? Why is throughput not a good idea there? What would you use instead?
So me personally, if a customer does ask us to do some active testing and get some real world that throughput data, what I usually will say to the customer, I say, yeah, that's absolutely fine, we can do that. But what I think would be better is if we grab your LCMI, which is the least capable, most important device on your client network. So, for example, if we're doing a warehouse, we might want to grab the barcode scanners that are going to be in use. If we're doing an office environment, we're going to grab the laptops that are going to one of the model of the laptops that are going to be in use. And what we actually want to do, we want to connect to the network, the Wi-Fi SSID, and then we want to test some real world applications. So if they're going to be doing lots of Skype calls, lots of Zoom calls, lots of WebEx Teams calls, what I've done before in the past, Mac, you might get a random call from me whilst you're sitting at home and I'm on site and I'm calling you from WebEx Teams and just testing out how it actually performs whilst I'm in certain locations. If I'm stationary, if I'm actually moving around, how does it work when I transition between access points? And test the least capable, most important device using the actual real world applications that the customer's going to be using and doing some tests that way, rather than relying on the active test that you can do inside of your survey software, because it can sometimes look like you've got a really bad performing network when really it was just your device having a bad time at that moment in time for that specific reason. And it might not even be down to the poor roaming decision of your laptop or your mobile device. It could be that there's another part of the network that was having a bad time at that moment in time as well. So what if the DHCP server's gone down, the DNS server's gone down, the firewall, someone's applied a new policy and all of a sudden everything's getting throttled and not working quite so well. And the other thing to remember as well, ping is the lowest priority on a network. So, if there's other traffic that's trying to go ahead of that could get down prioritized and your ping times could look really bad. And it gives a false representation of actually, the customer could look and think, oh, I've got real slow ping times over here. My round trip time is really bad. We need to go fix the Wi-Fi over here, where really you haven't got a Wi-Fi problem there.
Yeah, so your voice packets, they can still be flowing nicely while you just can't get the ICMP packets into your Wi-Fi network, because every single frame that you want to put in the network has to play the game, right? And by playing the game, you are using different contention window queues, pseudo-random numbers. We won't dive too deep into that here, but normally in a well-configured network, voice or video packets, they will have better statistical advantage when it comes to the chance that they have while trying to transmit their frames into the Wi-Fi network. So yeah, don't look at ping. Additionally, in Ekahau, what I have discovered with Matt is when you roam, and even though when you just lose network connectivity very momentarily, like for just several milliseconds, you have a very fast roaming, but Ekahau did notice, at this point in time, you've lost like a packet there, just one, maybe two, maybe five, not too many, okay? And it will show you that you have ping failed 100% of the time. And then when you have connectivity restored, you roam to the next best access point and you are back on the voice conversation. You just heard like a and now you're back, you're happy using network again. Ekahau will go, okay, so you used to have 100% failure, now you're 90, 80, 70, 60, 50, 40, and then you go back to 0% fault. 0% fault, at which point you must have walked like 10 meters, okay? And then the radius of a low RTT, low ping, gray color or red color on your map in Ekahau heat map, it will look very scary, while in fact, you've just had a very quick roaming event, okay? That took, 55 milliseconds. It just looks bad in Ekahau. It looks way worse than it really is in the real world, so be careful with that. Additionally, when you have bad throughput tests results from the ePerf server, iPerf server, poor ping results, and even if you fall you have like a very low RSSI levels, it might be still very good for your barcode scanner for its operation, okay? Because you just need to put some text into the shared medium that the Wi-Fi is, and the text is just a telnet stuff. It's very small packets and sent very infrequently, and even if it's like delayed by 400 milliseconds or delayed by half a second, it doesn't matter, okay? So you scan, if it's like instantaneous or if you have to wait for half a second, it doesn't matter really. It still feels quick. It might not be good enough for voice, but it's good enough for the scanner. So you have to be mindful of what you're checking your network against, okay? What is the success criteria? You have to have extremely well and clearly defined requirements for what your Wi-Fi should be capable of doing, what applications you are going to use with what devices, and then based on that, your design should be done based on that information. And then you just have to test with a real application, with a real LCMI, least capable, most important device. That's pretty much it when it comes to the active survey.
Well, I did mention earlier that I might, throw a curveball out there, and you may or may not agree with me here, but I do think that if you have got a requirement from a customer that they do want to see some active results in your Ekahau survey reports, and that's fine. Then what can we? Is there anything that we can do that might actually be a more fair representation or some better ways to test? And I know we had a little discussion beforehand. I'm not sure you definitely agree with me, but what I think is a feasible option, and what you could do if you did want to collect the active survey data in your Ekahau project file and then put it into your report, what I'd recommend you do with the customers, you say you're looking at the floor plan with the customer, what I would say is that you agree some certain key areas that you want to go do some of this throughput testing at. Say you agree 5 locations on the floor plan. What I recommend you do, you go to that first location, and when you get to that first location that you've agreed with the customer, what I recommend you do, disconnect from Wi-Fi, reconnect to Wi-Fi, and then inside of Ekahau, now use a stop and go mode for collecting the data. Stand stationary, hit stop and go survey, let it count down the 5 seconds, collect the data, and then you've got your throughput information for that position whilst you're on the map. And you might be asking, why have I said to disconnect and reconnect to Wi-Fi? Because sometimes your device may or may not roam to the best access point when you're just transitioning. And I think to give a more fair representation of how the Wi-Fi is working in that area, you help the network out a bit, disconnect from Wi-Fi and then reconnect, and hopefully your device, caveat, it might not connect to the best access point. An access point down the hall might respond on the channel faster than another access point whilst you're scanning and doing your probe requests and gathering your probe responses. But there's a good chance that you will connect to the best AP for that location. And then now when you do your throughput tests inside of Ekahau and you just use a stop and go and you stand in the same position, you're not gonna, you shouldn't have roaming factors being played in, moving away and, dropping down the signal strength and the SNR and the data rate, because you're stationary and hopefully it's going to stay roughly the same. Then what I recommend you do, move to the next agreed location that you discussed with the customer, go to that position, disconnect from Wi-Fi, wait a couple of seconds, reconnect to Wi-Fi, do your stop and go again, and collect the active survey data. So then when you go back and you review the active survey data later on in your project file and you want to include some of that in the report, you can just go look at that information in those positions of your stop and go data. And I think that's a more fair representation than if you just do it continuously whilst walking around, because you're going to have potentially a bad looking network for reasons because of the device in that particular time at that particular moment for that particular reason that hasn't really got anything to do with the Wi-Fi.
And clients, they are very sensitive while looking at heat maps, so they might be like questioning your work, saying, oh, so you are just next to this massively amazing expensive access point that we just put in last week, and you have just throughput of 10 megs there. Why is that? And you are connected to the AP 30 meters down the office, okay, because it's still good enough for your device. Your device thinks it is good enough for itself. Also, different devices that will sometimes be very clingy, very hoggy, like sticky to the access points, like not looking too far, on my desk, my MacBook, it has a roaming threshold of next 75,
Yep,
which is very low. Okay, it's very low. So when I have a Skype conversation with Matt on my MacBook, and I walk around the office, I'm guaranteed to have drop-offs from the conversation. Best case scenario is I will hear like a massive cracks. Worst case scenario is I will just disconnect. Okay, because MacBook, let's say, it's not designed to be a mobile device. It's designed to be closed, moved to a new location, and opened on a new desk. And then it makes the association decision. Should I stay connected to the last access point that I was connected to? Should I look for a better alternative? This kind of stuff. And also, word of caution here, MacBooks, they don't support, well, they will connect to the SSID. They will associate to the SSID that has like 802.11r enabled, but they are not using it, okay? So they will always go through full reauthentication, and this will make roaming on these devices very slow. So that's just for Apple, okay?
Especially if you're using a .1x configured SSID where you've got to do radius authentication.
Yeah, it cost me many hours and annoyed clients. Like we were doing some roaming tests with MacBooks in the past, and I was troubleshooting a problem that wasn't a problem to begin with. Okay, I was trying to make the MacBook roam fast, and I couldn't. And I was scratching my head, thinking, why is this device so slow? And the answer is because it's designed not to be fast. Okay, it's designed to conserve the energy. It's designed to just sit on the desk or on your lap and work there. On the other hand, when you take a flagship Android or an iPad or an iPhone, they are extremely quick to roam, right? They are super quick to roam. And it's also funny because they use clear to send, request to send all the time, these devices from Apple. You would think that they add more data management and control data overhead. It does, but Apple thinks that it contributes to the better reliability of a network. There must be something to it, right? So if they are using it, then they probably have done a proper research, because they have like 100-something people working on the roaming algorithms only, which is a lot of people knowing what they do while making these decisions.
Yep. And remember our customer that we had over in Barcelona, they weren't happy when they were running their speed tests, and they were getting around 150 to 100 and something megs for their performance of the Wi-Fi, because we were using 20 megahertz wide channels only, and they just moved from previous office where they had 80 megahertz wide channels configured on 5 gigahertz. But we decided we wanted to keep the 5 gigahertz spectrum a little bit more cleaner, reduce the co-channel contention from not having all of the access points on 80 megahertz wide channels. But Mr. Customer went there, they run their test, and oh man, Wi-Fi is so slow here compared to the other office. Like, why, this is a brand new Wi-Fi network that we've just put in. Like, why is it slower here than at the other office? If I connect via LAN port, I can get 1 gig, speed test. So we tried to explain to the customer, it's rather than getting a higher speed test, it's going to be better to have a cleaner spectrum. It's not so much channel contention. It's going to have a much better feeling, and work smoother and have less performance issues than just getting a fast speed test. But the customer still wasn't too happy and decided that they wanted to get the faster speed test results. So we eventually caved in, and we went from 20 megahertz wide channels to 40 megahertz wide channels so they could get their faster speed tests. But the other thing that you have to try and bear in mind, and you think when you're doing your surveys and you're designing for your network, is how much data rate does a device really need. If we look at what we are using right now to record this podcast, I look at my statistics. I'm doing 340 kilobits up and down roughly, and I'm streaming HD video, voice. There's other stuff going on in the background, and I'm using less than half a meg on my device. So really make sure the expectations are set with the customer, what applications and requirements are going to be in need, because usually we find customers kind of want to go with, my device needs to have 50 meg because I upload files or download files or I stream, blah, 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 blah. But in reality, they're not going to use that much.
And even if they do sporadically, it's not going to be all the time, right? Even if you have a client that is working with massive CAD files over the Wi-Fi network, how often are they going to upload the CAD file? Every time they hit save button, how many times a day do they hit the save button? Once, twice, 5 times? How big is the file? 100 megs, 200 megs, 500 megs? If you have, 200 megs real data rate, is that a problem? would it make a massive difference if you had 1.3 gig or if you had 4 gig data rate? Every time you use wider channel, you introduce more noise into the channel, your SNR drops, you are more prone to getting to the point where you will have to retransmit the data. You won't be able to understand the acknowledgement from the access point and the other way around. So it's pretty much in the enterprise environment always better, pretty much always, not always, most of the time, to just go to 20 megahertz channels, make sure that you have the highest available SNR, that you have lowest available contention, and that you can always put the data into the air reliably when you want to put this data there. So you can reuse the channels. So you have more capacity at the expense of the raw speed. And this client, a client of yours in Barcelona, I know that they were reporting network issues prior to upgrading to a new network with their 80 megahertz channels. And they had this massive, amazing speed test results in their busy office in the middle of the night where everyone went home. And then, yes, you will have amazing speed test result, but will you still have the same result with entire office, workforce in the office, working in a Wi-Fi first environment, doing their daily job, contending for the airtime? So instead of having, 20 non-overlapping 5 gigahertz channels or 19 or 16, whatever, depends on where you are in the world, you are now down to 1 or 2 or 3, and everyone is waiting for the turn. They won't be able to speak when they want. If they have the transmit opportunity, it will be very fast, but getting the transmit opportunity will be difficult and it will feel super slow. Okay.
Yep, completely agree. So let's summarize then. When we go to do a site survey, Mac, should we be doing a passive site survey or should we be doing an active site survey?
Always do a passive site survey unless you know what you're doing and you have a certain condition, certain scenario to test against while doing active survey, then always do passive survey. And if you do active survey, always use the application that your client is going to use in a network that was designed for that application. That's not always voice. It doesn't always have to be super fast or super smooth or fast to roam. Sometimes it's just, basic data coverage in the warehouse full of scanners. Sometimes it's not. So be mindful of the requirements and success criteria.
Perfect. Thank you, Mac.
You are very welcome.
Okay. Well, I think that probably wraps up what's the difference between a passive and active site survey and which one you should use when you're conducting your site survey. So we can end the podcast here.
Okie doke. I think it was a very valuable discussion.
Yep. Thank you very much, UK Wi-Fi Slack channel, for giving us the idea for this topic. And we hope you find it useful and we will see you on the next episode.
Of course. Thank you very much, guys. Take care. Bye-bye.